So let's learn a little bit today about the metric system, which is the basis of measurement that we'll be using in chemistry class and presumably for the rest of your scientific career, no matter how far you go. So the metric system was devised in late 18th century France in an attempt to standardize values of measurement, whether it was for mass, whether it was for length, and whether it's for volume, temperature, and so forth. And also to simplify measurements. For example, the way the English system of measurement from back in the day is based on is the idea of inches, and then 12 inches make a foot, and 36 inches make a yard. These are somewhat awkward numbers to work with as we start building up units of length. So when we get into the metric system where things are based on ones and zeros, binary powers of numbers that form powers of 10, measurement becomes easier. So the metric system is not only meant to standardize values, but make the math, make the calculations simpler. So a third aspect of the metric system was an attempt to unify measurement under a rational idea of connecting values as much as possible, uniting the idea of length and temperature and mass and so forth. And by the standards of the day, this was an excellent system. And it was decided in many respects that the core center that hooked together the new system of measurement was based on the properties of water, which on everyday life makes sense. Much of the Earth's surface is covered by water. It's one of the essential things that is needed for life. It's present everywhere in the experience of all living things on Earth. So whereas it may not apply quite so well once we're out in deep space, it's excellent for everyday life on planet Earth. So what was decided was that we would unify our systems of measurement around water. So I have some standardized weights and measures. And of course, these are not as accurate as the universal standards that are kept in Paris, France, but they are pretty close to the universal idea of a gram, which is of course a tiny little piece of brass right here, or its multiple of 1,000 known as a kilogram. So a gram of water, which is representing mass, occupies 1 milliliter, that's volume, or a cubic centimeter, which is the same value as a milliliter, except it's sort of in geometric form. So it's basically the length of a volume of that water drop, square cubed, there's the cube symbol, and that it will occupy that volume if the temperature is right at 0 degrees before it gets colder and it freezes. If the atmospheric pressure is 1 atmosphere, which is basically the pressure, atmospheric pressure on a sunny, clear day if we're somewhere at sea level on planet Earth. So that's a unification of ones and zeros. So you see how much simpler this is. This was the first systematic attempt to start uniting things like mass, volume, length, temperature, and pressure. We also get into the early stages of a very important idea and a very important concept of measurement in science, and that is energy. And this word actually was not really a common part of scientific vocabulary until into the 19th century, but energy was a calorie. And so if we had a gram of water and we wanted to heat it up by 1 degree, 1 gram, we need 1 calorie of energy. That energy could be electrical, it could be heat, it could be whatever. And we still use calorie in everyday calculating of food energy. Now, calorie has been since replaced with the idea of the joule, which is more united with the contemporary scientific idea of temperature, which is known as Kelvin. But for practical use, we will use these measurements. We, of course, will always be using grams, milliliters, cubic centimeters, and atmospheric pressures. Temperature, we can, on everyday life, in basic lab work, we can do use the Celsius system here. That's what the C represents. And we could use calorie if we are uniting the idea of energy to the Celsius system of temperature. When we get into gases, we'll need to replace the idea of calories and Celsius with Kelvin temperature and joules of energy. But by and large, for everyday life and for much of practical science, we are still using the metric system. As we get deeper into science, such as thermodynamics and gases, we will move more into what's called the International Standard System of measurement, which still preserves things like grams and milliliters and stuff like that. But for now, this is right where we need to be. So get rid of your idea of pounds and inches and things like that. Let's hop aboard the metric system.